okay? For example, in this example, when you have a baseline in 2000, this one was run, I think, with a baseline in 2020, so you have a result in 25 and a result in 2030, okay? These are all parameters that you can set. So let's have a look how we can display the results. So let's see, instead of Ghana, let's use Benin. That is a little bit smaller, so we can see the result. We can see the result probably quicker, hopefully. So here I start by using this is Benin, yeah, okay. Here I start by using the population vector that we created in the first step. And now you can map this polygon according to the scenario that you want to display, okay? So if you are in Quantum GIS, how you load the different scenario, you can use the vector. Let's see. Add a layer, yeah. Add what you have, the limited text layer, I think is this one. Okay, so we can probably there are different ways to do it. Let's see if you can add the layer by using this the limited text function in Quantum GIS. So you select the file name that is basically the scenario that you want to display. The file format is CSV. The X field is X and Y, and here you can see all the fields that are going to be added. Okay, and just to check that they are in the proper format, if you need them. Okay, here you have the first column is the code, and then you have another column that is the ID. Okay, so for if you created in the just an additional column that is basically the a progressive number is going to be probably placed at the beginning of your CSV file, but if you use like I did an ID and use this ID to create the population polygon, this is the ID that you can use to join the table to the map. Okay, so I'm going to show you. I'm going to try now to see if we can do that. So when you add it, I already added here, so you add it, and then what you get is a point shapefile. Okay, this is the annoying part, right? Because we work with polygons, but we get points. You see, so the points are basically the centroid of the initial polygons, but we don't want to map the points because it's a massive cloud of points, but we want to map and classify the polygons. As you can see, when we talk about centroid of polygons, sometimes they are inside, sometimes they could be even outside the polygons if the polygons has a different shape. In this case, you can see this typical shape of the polygons happens because we create polygons by using raster. So what we should do now is to basically join the information that we have on the points to the polygon to classify and create our map, okay? Because if we open the table here of the points, it's going to take a while. You can see that the points have all the results that are in the CSV file because we create this polygon by using the CSV file. But in the polygon, we don't have nothing. We have only the ID at this point because I eliminate also all the other information. So we need to attach the information to the polygon to be able to create a map and display and classify the map. So we do that. It's a simple join. You have two options here. You can join by ID, or you can join by using spatial join. Okay. So let's see how it works here in QuantumJS. I already use it. So join attributes by field value. If you use the field value, you basically use joining the ID. So the our Benin, the population file, we have only the ID, and the second layer is our point file that we just created. And okay, the fields, you see, we have a lot of fields, and the join field is the ID. Okay, so we link like the information that are in the CSV directly to the polygon. Join type, 1, discard if something goes wrong, and open output file after running the algorithm. Let's see if it works. We run it. Let's see how much time it takes. Not a lot. It was very quick here. And now we have finally, for this scenario, okay, the baseline with all 0 here, we have polygons finally. And in these polygons, we have also the information that we need. Okay, so if you want now to classify these polygons, you can use Quantum GIS to classify it, or you can use ArcGIS if you want, or other software. Okay, so for category, here you have let's see, you have several fields. So we want the minimum overall in 2030. And we classified, and you see that now we have existing grid, and we have all the different layers. Okay, so if you classify like that, you can see which are the population cluster in which you should use the existing grid, and which are the hydro, which are the hybrid, and which are the solar power grid. Okay, so if you can, in this way, you have something very similar to the output of the energy data info. Okay, sorry, 1 second. So let me see if you have the JEP platform. Is in the other, so in the other one here. Sorry, you can see here that you have this kind of representation of a different scenario when you have, the summary and the core of the polygon that represent the technology. Okay, so this is how you display the result in a map, and then you can create, your output, your template, your maps, and then you can also do your analysis if you want. Okay, so there are different types of data visualization. Is up to you. Another thing that you can do by using the code available is to summarize the result. Okay, let me see if I have it in Excel here. Yeah. Another type of output that you can create is this one. That is very simple. Like I did this for Kenya. So instead of having all the result for each polygon, here in this way you summarize the result by country. So you see that all your different scenario could create total information by country. Like in this case, you have the population connected, the population connected to the grid, by using wind, solar PV, hybrid, hydro, the cost. This is all the information that are in the CSV file, but they are summarized for the whole country, okay? How you do that? By using the linkage. So let's see if I can show you this last step. Yes, here, okay, this linkage documentation here. You have the code. And here it is, okay? So when you use this script, basically the script is gonna read all the file in the output folder, like this one. And sorry, the output folder here. In the training, we said before, we have the result. Okay, so when you have output folder like this one, okay, now I found the one for Ghana. You see that the one for Ghana are, for example, here more than 7 gigabytes. Some of them could be like over 20 gigabytes. So when you run the script, even if it creates an Excel spreadsheet that is very small, it takes a lot of time because it needs to read all these CSV files that are several gigabytes and summarize the result in another short Excel file, okay? So you have this different option to visualize and analyze the result. Again, it's up to you, but in this way you can summarize and have a generic result. And by using Quantum GIS or GIS, you can have your maps, okay? So please let me know if you have any other question. And otherwise, I hope that you have all the information that you need to display your result, okay? So thank you, and good luck with OnSSET.